trigonometric functions. You might have heard of their names. Today, I'm going to give a precise definition to each one of the 6 trigonometric functions. So let's take a look at their names. The 6 trigonometric functions, they are called sine, cosine, tangent, cotangent, secant, cosecant, etc. So let's just read the 6 names because we're going to define each one of the 6 functions. So sine, cosine, tangent. Of course, there's a cotangent here. And secant, cosecant. Here, you just see 6 names. They do not have the same length. For our convenience, we simplify each name to a 3-letter abbreviation. Yeah, 3-letter. You see, sine function is abbreviated as SIN. Cosine, COS. Tangent, TAN. Cosecant, CSC. Secant, SEC. Cotangent. Okay, so only knowing names are not enough because how do we calculate, right? How do we determine a function value? So what are these functions exactly? So let's take a quick look. Actually, before we start defining the 6 trigonometric functions, we need to see in a right triangle, can we get the length of each side of the right triangle? So this formula is very useful because it is a 2-point formula that is for any 2 points, you can calculate the distance between them. So this is the distance formula. That means all you need is to know the XY coordinates of each point. You see, I have first point, XY coordinates denoted by X1, Y1. The second point, B, its XY coordinates are denoted by X2, Y2. So the distance formula is, you see, square of the difference of X coordinates. Yeah. And then plus square of the difference of the Y coordinates. So you do the difference of the Y coordinates and square it. So then you do the sum of squares. You get a number, right? You take a square root. You will get the distance between the 2 points. Let's look at a picture that shows the 2 points and then how to calculate the 2 points. So from this picture, you see A with X coordinate, Y coordinate, the B, another point, and the distance between them will be this lines, the length of the line segment, right? We want to figure out the length of this line segment. But for convenience, we introduce another point that is, suppose we introduce a right triangle. So this the vertex C is actually, the vertex C has x2, y1. That means this point, we can make it a little cleaner. So this C has the same x-axis as B, same y coordinate as the point A. You see the y1, right? So the C has the same y coordinate as A and has the same x coordinate as B, x2, you see, x2. So now we have a point. That means this point is going to create a horizontal line with A, with point A, and vertical line with point B. Yeah. So this is a very special point because it forms a right triangle. So this right triangle, then we're going to make use of this point because it's easier to figure out the length of the horizontal line segment. You see these 2 points, all we need is to calculate the distance between the x coordinates. It's horizontal because the y coordinates are the same. So we just find the difference of the x coordinates. So take absolute value of the difference. That's the length of the horizontal line segment. So for the vertical line segment, let's look at, that is the B and C, and they have the same x coordinates. And so BC is a vertical line parallel to the y-axis. So all we need is to calculate the difference of the y coordinates. So the length of the vertical line segment is simply y2 minus y1. Doesn't matter which one is minus the other because we take absolute value, right? To make sure it's non-negative. So that's the length of the vertical line segment. Now, with this right triangle, we can find the distance between AB, because the distance between AB is just hypotenuse of the right triangle. So use the Pythagorean theorem. Yeah, so we have the leg, right? The length of one leg, the length of the other leg, we already discussed. For this right triangle, we know the length of 2 legs, and then the hypotenuse, the length of the hypotenuse, which is the distance between the 2 points, AB. So by Pythagorean theorem, the hypotenuse squared is equal to the sum of squares of the 2 legs. So because the x1, y1, x2, y2 are all given, so we can find this quantity. And the d squared is found, so d must be square root of this quantity. So we have the formula. So now this absolute value can be replaced with parentheses because you square it, right? It's always non-negative. So you don't need to write absolute value. So we can just say x2 minus x1 squared plus y2 minus y1 squared, and take a square root. So we get the distance formula. It's a very convenient formula because any 2 points, no matter they are going to generate a horizontal line segment or vertical line segment or other like a segment that's in this fashion. So any 2 points, as long as you know the xy coordinates of the 2 points, you can find distance between them. So we applied Pythagorean theorem to derive this formula. So to take a closer look at the distance formula between the 2 points again, just remember that's all we need to do. So now let's apply that formula to a very special case. So in this case is, you see you have 2 points. And this one of the 2 points is origin. So let's call it 0, 0. So xy coordinates of the first point. And this is the second point, which is xy, which is simply a point on a terminal side of an angle, theta, which we call theta here. So this angle theta, we can always place it in a standard position. So what is the standard position? Just think of our angle, right? So the initial side coincides with x-axis. Yeah, so that is the vertex of the angle is at the origin, and the initial side coincides with the positive x-axis. And then this angle is in a standard position. So if the terminal side of the angle falls in the first quadrant, we say the angle is in the first quadrant. Whenever the angle is in standard position, and then the position of the angle is purely determined by the terminal side, right? So if the terminal side of the angle of an angle that is in standard position falls in the second quadrant, then we say this angle is in second quadrant. So that assumption is that based on the assumption that the angle is in standard position. Okay, so now we look at such an angle that is in standard position, and then we can immediately pick a point, right? So the point on the terminal side. This point is arbitrary. Yeah, it doesn't matter which point you pick. For example, you can pick the point here a little closer to, yeah, so that means you form a right triangle, which is similar to the other right triangle. So that means the point is, as long as it is on the terminal side. Okay, so suppose I have such a point, and we have a right triangle now. Because from that point, I know this is the x, the value of the x coordinate. This is a y, the value of the y coordinate of the point. And immediately we can use that, and we know also the hypotenuse. Hypotenuse is the distance between the origin and the point P. Yeah, let's apply the 2-point formula, because x coordinate minus the other x coordinate, which is 0, right? Squared. The y coordinate minus the other y coordinate. Yeah, difference of the y coordinates. So we're trying to apply 2-point formula to the O and P. So to decide the length of the line segment of OP, that is the hypotenuse. So then we will get square root, right? That's the 2-point formula because one point is origin, the other point is the P with XY coordinates. And then we have square root of x squared plus y squared because x minus 0 is still x. 1 minus 0 is y. So yeah, so the formula is simple because one of the point is origin. So immediately we have the r value, which is the hypotenuse. Now, as long as we have x, y, and r, we can define 6 trigonometric functions for this angle theta. So let's look at the sine. Yeah. Oh, the sine. Let me pick a color. This sine theta. You see, sine is a function with theta being input of a function. So that means your function value is really depending on theta. Yeah, for this particular theta, certainly we have a point from the terminal side of theta. And then we are going to calculate sine theta by this ratio, y over r. So you see the ratio y over r is the sine value. And cosine theta is x over r. X over r. Remember r, as long as you know x, y, you can calculate the r as the sum of squares of the coordinates. Yeah, so we can calculate sine, cosine. And then we have 4 other functions. And let's define tangent. What is the tangent theta? Tangent theta is y over x. Yeah, after we have the 3 functions, and then let's just write all 6 functions. Yeah. On the next page. So let's. So these 3 functions, and then we can define 3 more functions. The cosecant theta. So your sine theta is y over r. Cosecant theta is r over y. Suppose y is not 0 because sometimes this point on the terminal side is on the x-axis and the y can be 0. So, but in that case, the cosecant is undefined. So we have to be careful that we can never define this ratio, right, if y is 0. So you will never divide 0. But r is always positive. So the sine function is always defined. Cosine function is always defined. tangent not always defined, because when x is 0, the tangent function is undefined. So we need to indicate that. Yeah. So it is tangent function is only defined when the x is not 0. And then let's look at secant. What is secant theta? You see, cosine theta is x over r. Secant is actually r over x. Yeah, reciprocal of cosine if both functions are defined. But cosine function is always defined because r is always non-negative. But secant function is undefined if x is 0. That means it is only defined when x is not 0. So one more function, cotangent. Cotangent function, which is abbreviated as COT. Cotangent function for the same theta, it is the x-coordinate of the point over y-coordinate of the point P, which is on the terminal side, right? The point is on the terminal side. X over y, you see, if both tangent and cotangent are defined and they're reciprocal to each other, yeah, so tangent is y over x, cotangent is x over y. But cotangent function is defined only when y is not 0. And tangent function is defined when x is not 0. So now we have all 6 functions. And if they are all defined, you can see the first 3 functions you can remember easily. Just get used to it, right? So the sine is y over r, cosine at theta is x over r, tangent at theta is y over x. And the other 3 is, yeah, are those. I just gave precise definitions of all 6 trigonometric functions. Now let's try to apply the definitions and to work on this angle theta. So you see the theta is given. It is in standard position, and we have a point P on the terminal side of the angle theta. And we're ready to calculate the 6 trigonometric function values for this theta. But we need r, right? The hypotenuse. So let's calculate the r first. R because for this x coordinate and y coordinate, so we calculate r using the formula. So we can, for this right triangle, yeah, that r is simply hypotenuse of this right triangle, as you can see. So r can be quickly found as square root of 12 square plus 5 square. So it is 12 square is 144, 5 square is 25. So square root of 169, which is 13. Yeah, we take only positive square root. Although there's a, yeah, we only take positive square root for the length of the hypotenuse of the right triangle. So once we have r, then we're ready to calculate sine theta. Sine theta is y over r. Y is 5. See this 5. y over r. R is 13. Now, cosine theta is x over r. X coordinate of the point. See, x is 12 over r, which is positive 13. And then we continue. Tangent theta. Tangent theta, y over x. Y is 5. X is 12. Now we have found the 3 trigonometric function values for theta, for the given theta, which is in the first quadrant, right? Because its terminal side is in the first quadrant. Now we continue to move on to the other 3 functions. So can we calculate cosecant? Cosecant theta is r over y. So 13 over 5. Secant theta is r over x. R is 13 over x, 12. And cotangent theta. Cotangent theta, the same theta. Okay, we have x over y. X is 12, y is 5. So for this particular theta, we used this one point, see, on the terminal side of theta, and we found all 6 trigonometric function values. And a quick observation, you can see that sine y over r, cosecant r over y, they're reciprocal. Cosine x over r, secant r over x, they're reciprocal to each other when they are both defined. Tangent is y over x. Cotangent, x over y, they're reciprocal to each other when this these two functions are both defined. So then we see some reciprocal properties from the definition. And we can pick another angle. So we just calculate all 6 trigonometric function values for this particular angle theta, right, in the standard position. And then we can have x, y, and r. And we use definition. We got all of them. Yeah, sine, cosine, tangent, cosecant. So just before we apply the definitions again, I want you to actually review it quickly. You see sine is always that definition. You just apply it. Y over r. Cosine, x over r. Tangent, y over x. Cosecant, r over y. Secant, r over x. And cotangent is x over y. So just the last one. Yeah, cotangent, x over y. So for this function, for this angle that is in the first quadrant, we see that x, y must be positive because terminal side of the angle is in the first quadrant. So a point on the terminal side must have positive x, y coordinates. And therefore, all the 6 trigonometric function values are defined because you're you never divide anything by 0, right? Because you see all these x, y are positive, so you have no worries when you divide a positive number in. So they are all defined. All 6 trigonometric functions are defined. Now, I will show another angle that is in the second quadrant. This angle in the second quadrant, so it's easy to see that this angle alpha, let's call it alpha. Yes, that's the name of this angle. You see this angle is bigger than 90 degrees, right? It is an angle whose terminal side falls in the second quadrant. And if, although the exact measure is not given, but you're able to visualize this angle. So that angle alpha, if you know the terminal side and you know the angle is in standard position, then it's a very specific angle. And I want you to calculate the 6 trigonometric function values for this angle alpha. How do we calculate? So let's follow definitions. So yeah, we pick a point whose xy coordinates are -4 and 3 respectively, x and y, and we still need r value, right? R is the distance from origin to the point P. So we just get R first. So which is square root of x coordinate squared plus y coordinate squared. See, we know the x, y coordinate. So then that is 16 plus 9, so square root of 25. So then we can get number 5, which is square root of 25. So R is 5. Now we're ready to calculate sine, cosine, etc., all the 6 trigonometric function values for this alpha. So let's write sine alpha is, if you remember the definition, let's apply it. It's y over r. What is y? Y is 3. So 3 over r, which is 5. Now cosine alpha. Cosine alpha is, by definition, x over r. X coordinate of the point is -4 here. -4 over r, which is 5. Now tangent alpha. See, the same alpha, we can find 6, we can evaluate 6 functions at the same alpha. So tangent alpha is y over x. Y is 3, x is -4. So right now we're simply applying definition to this angle alpha. Then continue. So we want to calculate, okay, to have you memorize the other 3 functions. I'm going to use this format, like cosecant. Cosecant alpha. Cosecant alpha is r over y. R is 5, y is 3. Secant alpha is r over x. R is 5. X is -4. But of course, you can put a negative sign in the front. So -5 over 4. So cotangent alpha is x over y, which is -4 over 3. But you can put a negative sign in the, in the front of 4/3. Yeah, so, 4/3. So it's the same. So our final answer, so for the other negative values, for example, this cosine alpha, if you want, you can always put a negative sign here. So 4/5, -4/5. And for example, here, your negative sign can be put in front of 3/4. Yeah, so it's the same. So we got 6 values. Let me circle. This is for sine. This is for cosine alpha, that is tangent alpha. And then we have cosecant, and secant, and cotangent. They're all defined. By the way, you can see that some reciprocal properties, right? When they're all defined, and you easily see that the sine and cosecant alpha, they are reciprocal to each other. Cosine and secant alpha values are reciprocals to each other. Tangent, cotangent. Yeah, based on that definitions, if you see tangent, cotangent, right, they are also reciprocals to each other. Purely, if they are both defined, they are, we observe that property. Okay, so there is another angle. You can, again, try to work on it. It's just an exercise. I'm sure you have no problem doing this one as well. So just a very similar pattern. So I'm going to do it quickly. Just we try to identify this angle. This angle is a negative angle, right? You see beta? When we place the beta in the standard position, the initial side is along the positive x-axis. But this angle is clockwise. So its terminal side falls into the 3rd quadrant. So it's a negative angle, but doesn't matter. But this is an angle that is in the 3rd quadrant. So in order to find sine beta, cosine beta, etc., so all the 6 trigonometric function values for beta, right? Then we need to get a point on the terminal side. A point. Which point? Oh, we're given a point. You see that point P with x coordinate being -1, y coordinate being -3. Okay, then we still need R, which is the distance from the origin to the point, right? So, which is a square root of x squared plus y squared, y coordinate squared, which is square root of what? 1 plus 9, 10. Yeah, so R is square root of 10. So are we ready? Yes, we can now. For this angle, which is in the 3rd quadrant, sine is still the same definition, right? It's y over r, but this y is a negative number. And r is a square root of 10. But we don't like to have a irrational number in denominator. We want to rationalize it. How? We just want to multiply both denominator and numerator by a square root of 10. So let's it's like multiplying a 1. You see, we simply multiply this, both numerator and denominator. So we don't change the value, just we want to make it look nicer. So denominator square root of 10 times square root of 10, right? You will get 10. So then the denominator is no longer irrational. It is rationalized. The numerator becomes -3, but of course we can put negative sign here. 3 square root of 10. So that is the sine value. Now cosine value. So cosine value is x over r. X, we know it's -1. R is square root of 10. Same reason we don't like the irrational number in denominator, so we rationalize it. What do? So we just, for denominator and numerator, let's multiply both numerator, denominator by this 1, right? So this is, let me use a different color so you can see it's essentially you multiply a 1 because this is the number you are multiplying. So you didn't change the value. You only want to rationalize the denominator. So what is the result after you multiplying this quantity? The denominator will become 10. You see, square root of 10 times square root of 10, you get 10. The numerator will be negative square root of 10. So I put the square root of 10, but negative sign can be put in the front. Okay, we got cosine. Then tangent. So tangent beta is y over x. Y is -3, x is -1. So y over x, after we cancel the sign, the negative sign, you get 3 over 1, which is 3, right? So tangent. So now we are ready to calculate 3 other functions. And let's see, actually, because the other functions you have already have the first 3, actually the other 3, let's start with cosecant. Cosecant beta is r over y. R is square root of 10 over y. Y is -3. Now this time we don't need to rationalize denominator because it's already a rational number, right? Because it's integer, so it's rational. So we can put a negative sign in the front and just keep the 3 here. So that's the cosecant. Secant beta is r over x. R is the same r, which is the square root of 10. X is -1. So it's just the same if I put negative in the front. So negative square root of 10. And last one, cotangent beta. So cotangent beta is x over y. X over y. So -1 over -3 is 1/3 after we cancel the negative sign. So 1/3. So now we've got all 6 functions. So you see in order to get the value, so we had to make use of the xy coordinates of a point that is on the terminal side of the angle. And also the r value. R value, yeah. So once you get X, Y, R, then you are ready to calculate each one of the 6 trigonometric function values for the given angle beta, given beta, yeah. So we did this one. So all these angles, you see it can be in the first quadrant, can be in the second quadrant, or third, or fourth. But it can be also as a special, as a quadrantal angle. That is, the terminal side can fall on a certain axis, like x-axis or y-axis, like this one. So this angle, you see the terminal side. Well, this angle is certainly still in standard position, right? The terminal side coincides with y-axis. And we see immediately this is a 90-degree angle. But whenever the terminal side coincides with either x or y axis, then this angle is called quadrantal angle. So this is a quadrantal angle. It's still possible because we can pick a point. It doesn't have to be this one. For example, if you pick another point, instead of 0, 1, you pick a 0, 4, right? That's also a point on the terminal side. The reason we pick 0, 1 because it's just the y coordinate is integer 1. It's a simple, but which point to pick will not affect your function value. So actually, only this angle will affect the trig function values. So this angle is specifically a 90-degree angle, right? So for this angle, we pick, this is called gamma, a Greek letter. Yeah, so you see we have used alpha, beta, gamma, etc., or theta, those Greek letters. That's often the case. We use a Greek letter to represent the name of an angle. So now for this quadrantal angle, let's say we call it gamma. Then what is the sine of gamma, cosine of gamma, etc.? We want to decide. But still, we use a point on the terminal side of gamma. The point has x coordinate 0, y coordinate 1. Then what is r? R is the, you see, the distance from the point to the origin. So it is a 0 square plus 1 square, which is square root of 1 is still 1, right? From the, it's easy to see it's the r is the same as the y coordinate. Yeah, so we can quickly, if you see that is a quadrantal angle, you don't have to use the formula. You can really quickly get r is same as the y coordinate. But absolute value of the y coordinate, because r is always non-negative. Yeah. So we have the 3 values. We're ready to find sine, cosine, tangent of this gamma. And okay, and also 3 others, right? So we can start with the first 3. Sine, y over r. Y over r is 1 over 1, which is 1. Cosine is x over r. X is 0 over 1. 0 divided by a non-zero is still 0. Tangent, y over x. Be careful. X is 0. So undefined, this is undefined. So the tangent of 90-degree angle is undefined. We don't have a value for this angle. The tangent 90 is undefined. And then let's move on to the three other function values. So first, let's try cosecant gamma. Cosecant gamma is r over y. R is 1 over 1, so 1. Secant gamma, r over x. R is 1, x is 0. See, because this point is on the y-axis. So x coordinate is 0, undefined again. So the secant is undefined. Last one is cotangent gamma. Cotangent is x over y. X is 0, y is 1, so cotangent is 0. So we have found all, actually, 4 trigonometric function values, but 2 of them, the 6, are undefined. So we have sine, cosine, cosecant, cotangent. But secant for the 90-degree angle, tangent for the 90-degree angle, they're undefined due to the 0 x-axis. That's the reason. So these 2 are undefined. So for quadrantal angles, it's possible that your certain trigonometric function is undefined.